Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. We are going to continue on with our presentations today, but to quickly recap on what we have done already, we have looked at the elements or different elements of weather and the different elements that we have already got the groups to present. The ones on temperature, the group that talked about temperature looked at the instrument that is used and also how to read information from the thermometer. Then we had the second group that presented the work on rainfall. They looked at rain gauge. We also had the group that looked at cloud cover, and they discussed about the octas or the octa, which shows us the different units in terms of eighths of the sky covered by cloud at a particular time. And we also looked at cloud type. For the students who did the work on cloud type, they discussed height being an important factor which distinguishes the different types of clouds, the low clouds, the medium clouds, and the high clouds. And we also looked at wind speed. I did not give you time to ask questions on wind speed in our last lesson, so we will start off today with the work on wind speed, and I will also allow time for anyone who would like to ask questions to that group who did the presentation on the wind speed. So we will get the group again on wind speed to come up to the front. If there is anything that they need to complete on their explanation on wind speed, they will do that, and then we'll allow for question time. And then after that, the rest of the groups to do their presentation. Okay, I will call now on the group which is responsible to look at wind speed. They will come back up here for the completion of their presentation. Yes, that's right. Explain the feathers also, the symbols, and you can maybe show with a sample on the board. The pointer.
I'll just talk further about the Bedford wind scale by observing the ways some objects are moved by the wind. At 0, the wind description is calm. The effect on land features, the smoke rises vertically. The speed is less than 1 kilometer, and the error indication is like a circle and a dot at the center. Number 1, we have wind description, light hair, effect on land features, direction, shown by the moving smoke but not by Windvane. Speed is 1 to 5 kilometers per hour, and the error indication is just half. 2, we have light breeze, wind felt on the face and leaves rattle or Windvane moved. 6 to 11 kilometers, and it's represented by a full arrow indication. 3, we have the gentle breeze, leaves and twigs in constant motion, and flags moved. 12 to 19 kilometers per hour, and it's represented by 1.5 arrow indication. 4, we have moderate breeze, rises dust and paper, small branches moved. 20 to 29 kilometers, and it's usually represented by 2 straight arrows, full. The 5th one is fresh breeze, small trees begin to sway, 30 to 36 kilometers per hour, and it's represented by 2.5 arrow indication. 6, we have the strong breeze, large branches in motion, whistling head in the telegraph wires, 37 to 49 kilometers per hour. Arrow indication, we have three full feathers. Number 7, we have the moderate gale, which is whole trees in motion, 50 to 60 kilometers per hour. And we have 3.5 feathers indicated on the arrow indication. Number 8, we have the fresh gale, twigs broken off trees, 61 to 73 kilometers per hour. And we have 4 full feathers on the arrow indication. Number 9, we have the strong gale. Slightly structural damage occurs, especially to housing roofs, 74 to 86 kilometers per hour. The arrow indication is 4.5. Number 10, we have the whole gale. Trees uprooted, considerably structural damage, 87 to 100 kilometers per hour. And we have 5 full arrow indication. Number 11, we have a storm. We have a widespread damage, 101 to 120 kilometers per hour. Arrow indication is 5.5. And the last one, we have the 12, which is a hurricane. Effect on land will be widespread devastation experienced only in some tropical regions. And the speed in kilometers is above 121 kilometers. Arrow indication is full 6 feathers. Thank you. Any questions?
Questions from the class? Any questions with regard to the Beaufort wind scale plus the anemometer for wind speed? No questions? Okay, Shelley has a question.
Does the Beaufort wind scale get checked regularly?
They usually place the anemometer on a hill where there is no there's clearing, there's no trees blocking. So if they're not using this, then they use the Bedford wind scale just by observing the way some objects are moved by the wind. Questions?
Okay, if there are no other questions, oh, sorry, there's a question here. Gideon, okay, your turn.
You mentioned something about feathers. What is its feather width in kilometers?
The arrow indication on the is a feather which shows 1 to 5 kilometers is just half, and from 6 to 11 kilometers it's just a full arrow feather, indicating that the Bedford scale number is 2.
Okay, maybe we'll put our hand together for this group here. Okay, thank you for the presentation. I think they've made it clear on 2 different instruments that can be used. The anemometer, of which is the instrument you use for measuring wind speed, and the Beaufort wind scale as explained there, where you can use some objects to help you observe the speed of the wind. Thank you. So now this time we'll move on to the next group for their presentation. Okay, we are group number 4, is that right? Or group 5? Okay, group 5, we are now over to group number 6. use a ruler because we don't have the pointer. Let's put this over just in case. Get your chart ready so to put it straight on.
Good morning. Me and my friends will be talking about on the topic of humidity. This is the instrument that is used to measure humidity. I'm gonna be telling you the names of the parts of this instrument. It is called a hygrometer or wet and dry bulb thermometer. The hygrometer consists of two ordinary thermometers. One is called the dry thermometer and the other is the wet thermometer. The wet thermometer has a container of water that sits at the end of the bulb of the wet thermometer. And on this diagram too, that's much more clear. And there's a piece of cloth or muslin that is hung from the wet bulb into the water. Yeah, that's a hygrometer used to measure humidity in the atmosphere.
Okay, I'm going to talk about how you read the hygrometer. When the air is not saturated, the water evaporates from the muslin. It's the muslin. And this cools the wet bulb and causes the mercury to contrast. The dry bulb is not affected in the same way, so the two thermometers show different readings. When the air is saturated, there is no evaporation, hence no cooling. The two thermometers shows the same reading. The difference between the two readings is therefore an indication of the air. The difference between the wet and the dry bulb is the depression, which shows the humidity.
I'll be talking about how to read the hydrometer. First, you find the difference between the dry and the wet bulb. So the wet temperature and the dry temperature. You find the difference that this is 21 degrees and this is 16. So you minus it, you get 5 degrees Celsius. 5 degrees Celsius is this. And the dry bulb temperature is 16 degrees. So you look across the table and then you come under 5 degrees Celsius and you get 54 degrees. 54 for the humidity. Percent, sorry. 54% for the humidity. How to read the thermometer readings is if there's no difference between the two temperatures, the air is saturated. If there's a small difference, there is high humidity. And if there's a large difference, there's the humidity is low. And that's how you read the temperature for the humidity. Thank you. Any questions?
Okay, questions from the class? Any questions? Okay.
Yes, Shelley.
What do you mean by the air is saturated?
I'll ask my friend to answer that.
When we say the air is saturated, we say that the air is free of water vapor.
Answers your question, Shelley? Any other questions for the group on humidity?
Are the figures in the relative humidity table stationary or do they change? Like, are they fixed?
The table was that we got was in the book, and yeah, it's fixed. Yes, that's.
And last question.
What happens if the dry or wet bulb thermometer have their reading not closer to the main degree Celsius, but just halfway in the middle, like point or something like that?
You get your difference from your decimal numbers, and then you round it off the answer.
Okay, I think with that, we should put our hand together for the group. Okay, maybe perhaps to help a little bit on Gideon's question, you're looking at the temperatures. The temperatures will differ in different parts of the world, depending on what the highest temperatures are, what the lowest temperatures are. So if you in the polar regions, where you have the column or the table for temperatures, they might go below negative or minus. That you can also indicate into that particular table. So it does not have to be always static, as in you must have 1, 2, 3, 4, 5. It will depend on the region of the world that you can actually come up with a table of such. But Gideon has, Gibbs has explained to us on how we can actually find the relative humidity by reading information or from the thermometer for the wet bulb thermometer and reading of the readings from the dry bulb thermometer, and using the table how we can find the difference to come up with the percentage for relative humidity. And again, the figures can change depending on which part of the world we are actually at when we want to take our readings on relative humidity. Does that make it clear for you, Gideon, on whether the figures are always static or not? Okay, thank you to that group. Now we move on to the next group. This time it's group number 7.
Good afternoon, class. My group and I are gonna be talking about the Windvane, which is used to measure wind direction. Wind direction is measured by a Windvane, which consists of a rotating arm pivoted on a vertical shaft. The arrow of the Windvane always points in the direction from which the wind blows, and the wind is named after this direction.
Okay, the diagram here shows how a wind vane looks like. This is the arrow that's freely rotating, and the four main compass points. And a wind vane is usually placed on a freely exposed place where like there's no trees and nothing that's blocking the direction of the wind. And for this case, the diagram here shows the wind is blowing in the direction of northeast point. So, yeah. Any questions?
Where would wind vane be situated or positioned to get an exact reading of the wind?
It could be situated or placed on top of roofs where there's nothing blocking the direction of the wind.
What type of material is the wind vane made of? Is it like heavy material or plastic or some stuff like that?
If it was made of plastic, I think the wind should have blown it off. But I don't really know what it's made of. So it's probably made of metal or something.
Any other questions for that group? Okay, one more. Val.
Why isn't there the 16 points of the compass on the wind vane to get the exact reading?
From the points, maybe you could use the 16 compass, like maybe the wind stops somewhere here. You could just say that it's maybe southwest, something like that.
Okay, I think those should be the questions we ask for this to this group here. We put our hand together for the group on Windvane. The point that you need to remember here, we are looking at the direction of the wind, and they've already mentioned and told you that it is the arrow that you look at to tell you the direction from where the wind is actually blowing. And in the case of this diagram here, the arrow is actually between. It's supposed to be between north and east, so it should be the wind is blowing from the northeast direction. Okay, thank you. We have the next group, which is group number 8, to present.
Afternoon, class. Myself and Ovio will be talking to you about atmospheric pressure, its measurement, and the instrument that measures atmospheric pressure. The instrument that measures atmospheric pressure is barometer. And there are two types of barometer: the Mercury Barometer and the aneroid barometer. I will be talking to you about the Mercury Barometer, and Ovio he will tell you about the aneroid barometer. I'll be talking about the aneroid barometer. This is an instrument called the aneroid barometer. The art of this instrument consists of a small metal box, which is this is a sectional diagram of the aneroid barometer. In this small metal box, it contains very little air inside. The top of this box, which is this box, this top over here. The top of the box bends slightly under the influence of any changes in the atmospheric pressure. The movement of the box top is conveyed by a system of levers. So I'll just write down this is the lever we have, all the system of levers. And here we have a spring. And then here we have the pointer. The movement of the box top is conveyed by a system of levers to a pointer, which moves across a graduated scale. When air pressure rises, the box top bends in. When we have the air pressure pushing down pressing down, we have the top of the box, it bends in. That's when we have the ascending air or area of convergence, where we have air pressure pushing down to the Earth's surface. The air pressure falls. When the air pressure falls, the spring pushes the box top upwards. Now we have little air here, and we have the little air here doesn't have the strength of pushing the box up, which is helped by the spring over here. There's no pressure pushing down. There's no air pressure, so we have the spring, which pushes the box top outwards. The pointer on this face over here, there are two pointers. One pointer on the face of the barometer indicates the current pressure, and the other pointer shows the former pressure before the pointer was adjusted. This is a diagram of a Mercury barometer. The pressure of air on the mercury in the container, atmospheric pressure. So
forces the mercury of in the container to move up the gl- glass tube up to about 760 millimeters. The Android barometer, although it is a large and instrument, it is very accurate and used in many weather stations. Atmospheric pressure is read in millibars. Yeah. The pressure can be measured when the amount of atmospheric pressure that pushes the on X on the mercury and forces it up the glass tube, and it is read off the glass tube and measured, and it is recorded. Thank you.
Okay, I think we also have time for questions from the class on those instruments that you have put up. Questions from the class? Okay, there's a question up front.
With the aneroid meter, how do you read it to get the exact reading on the aneroid meter?
Use the, yeah.
Okay, the aneroid barometer, it's not supposed to be moved. It has to be placed on a fixed position where when it's placed, we have accurate readings. For the scale, we have two pointers over here. One, it shows the reading before it was adjusted, and one, it shows the current reading. The readings over here, we have the measurements in millibars, as you can see. I think it's very small, so you can't see.
Val, does that answer your question, or did you want him to give you the readings on that? Okay, can you give the readings on that instrument now?
I'm not really sure if the readings for today's air pressure, but this aneroid barometer is malfunctioning too. So.
Check the pointers and at least give us a reading from one of the pointers on that aneroid barometer.
Okay, for the we have the black one as the current reading. The black pointer, we have approximately 28 millibars, and then the gold one, we have maybe the reading before it was adjusted. It's somewhere around 4 millibars.
4 and 28. Okay. We are going to be, we must at least be able to also make corrections when we're reading information for pressure. It's supposed to be in the thousands, 1,000 millibar and etc. We'll look at that later on when we get to making sure we know what low pressure is and high pressure is. The 4 millibars and the 2 millibars might be the difference between those, the pressure system and all that. So our reading should be around 1,000, yes, 1,000 millibars, because at sea level, that's where the pressure should be approximately around. Maybe we'll have only one more question. We have time for the last question on pressure. Okay, Noel has a question. And that's the last one. Last question.
Is a barometer used in a plane? If yes, then which type of the two is used? The barometer. Is a barometer used in a plane?
I'm not really sure about the use of barometer in a plane, but to my own opinion, I think it's not used in a plane.
Okay, Frank is going to answer that question for you.
Barometer, I mean, not really one of these two are used in a plane. Plane has its own special type of instrument that measures air pressure between the it's called altimeter. It's how high the plane is from the surface of the earth. If it's at a certain point, then it'll give a certain reading. Yeah. Thank you.
Okay. Did he answer your question? Okay, and because we've also run out of time, the presentation for pressure will be the last for today. The two students here also did some good presentation in the sense that this particular instrument was explained well in terms of how you could read information from an aneroid barometer. And also the second equipment that you can use also for measuring pressure is the Mercury Barometer. And perhaps I hope the diagram here gives you a fair idea of what that instrument would look like and how you can read information from this particular instrument. That also brings us to the end of our lesson, and the last group, you are going to do your presentation tomorrow. Okay, class, if you can stand up now, please. To the pilot teachers, our keyword for lesson 99 is barometer. Good afternoon and thank you, students.